Do you hear us at the QBB 132? Just lift your hand if you do hear. Okay, so we will be doing today's class from, is it Daniel? Okay. We will be doing from the different class today. So we will use the connection, but physically we will not come there. And if anyone, we will see. Pardon me?
There's nobody going to be here, so I'll turn the system off.
No, please keep it on just in case if a random student will come, we will notify. But it is only one time for this week. We will resume using QBB 132 again.
Okay, I'll leave everything up and running.
Okay, thank you.
You're welcome.
How was that fire alarm today? Like, you don't get to hear those.
Mm-mm.
They're completely gutting out the basement hallway, and they must have cut a wire to the fire alarms.
Just one off in the basement?
No, the whole flat into a bar. Because they're clean.
Yeah.
It doesn't look like any like actual cleaning needs to be done, but they're really cleaning everything. They pulled down every single ceiling tile, there's wires and everything.
I wonder if Danny downstairs.
If it was asbestos, they would have told us all to get out, and they didn't. And they weren't wearing any protective gear. So if it was, then I'm screwed.
Let's say a few years.
Let's hope it takes longer than you. But no, that was loud. And because we were like right next to it, the guy made it told us it was a false alarm. But everyone else who already evacuated to the union. But I just
so you had to stay in there while it was still going on?
well, I did for like 5 minutes, and I'm like, I can't do homework, so I decided to go over to the union. And that's when I realized that everyone else in the building evacuated. I'm like,
Did you tell them it was a false alarm?
yeah, as I walked in, I went to Sananda first and Jasmine. I'm like, yeah, this is actually a false alarm. There's no big deal. And everyone's like, oh,
Did
okay,
the fire department come?
no, and it's just police did though. I think he came over just to be like absolutely sure or something. I don't think the fire department actually came. So this building is like prime to go up in front of any moment. We did, then it floods. Now a bunch of bolts against us.
So the actual device for sound was near your office?
Oh yeah. I mean, I think it was closer to your guys' office.
It's I'm not there.
No, but Aaron and I saw Aaron come out, and he looked at the guy who was doing all the cleaning, and I could tell it was a false alarm because he just turned around and shut the door.
I see.
We could not hear you talking. The guy was going around doing like hand signals to us saying false alarm. Yeah.
What's up? I know. This is not angry. salty is the word. Maybe
Salty?
I'm not. Like one of my friends was. Yesterday? I think so, right? When did you do that? I was iTunes. Oh, it was here. I just want you. Yeah. Oh, it. Oh,
So try to restart and after this the push. And this is not mandatory if you have discovered how to do transfer of graphical information. If you're not sure, then I'm using this.
That's like if you're default start this okay. Yeah, it allows you to create. Okay. I was gonna say, I think it's gonna be the ones on there, so. Yeah, that wasn't. What exactly is like a cutoff for yeah, like if it was like within 5, okay. That was the question.
You there, Dimitri?
I guess I pressed it too early. Oops.
Well, announcement that I will repeat probably again if when more people will come. So if you do have graphical information tunneling, if you have figured out how to do it on your laptop or on Windows, please do so. But if you're not sure, if it is not working reliably, it is recommended to use the desktops here in the Linux mode. To go to the Linux mode, on the Windows you hit restart, or just
push the power button, and when it starts waking up, push F10 like 100 times, or maybe one time at the right instant. And then it will show black and white, black background white menu, arrow up until the top line. It will show something like Linux Mint. And then after screen for password pops up, select Studio and just click Enter. So there's no password. Why we are using it? There is no science. There is no benefit in it other than using graphical information tunneling. If graphical information tunneling is not a problem for you, you do not need it. Yes. Yeah. You can just select Studio and click Enter.
What time do you name what yeah, that's right.
So good.
Yeah, two or something.
So that was you guys. You know, you're like hooked up to the utility.
Yes, yes, and I was coming up and watching if anyone is in this room.
If anyone is in QBB, please come to Lead Hall 20 something.
I couldn't see anything. I could kind of hear like a little bit. It sounded like you guys.
But the screen is no, their screen projects what is on this screen. But we can push, we can show their screen.
Yes. I will repeat the announcement each time new person comes. If you did, now it is kind of personal for one. If you did figure out how to do graphical information tunneling through your laptop, then you do not need the following. If it is problematic and not non-reliable, we will use Linux on these machines. This is dual boot machines, and if you never seen Linux before, which I doubt,
I absolutely not.
you will restart F10 100 times,
Yeah, it's happened.
and then arrow up to Linux Mint or whatever it's installed, then Studio, and then hit Enter because his password is no password.
Is anyone in QBB 132?
Not each application. So, instead of solving this problem in your laptop, let's use this. And third,
building models will be we will complete it now. From in our later meetings, we will need graphical timing less and less. Most of things we'll be able to do just in the terminal connection. So even if we do not figure out how to do it reliably, we do it for sure today. Later on, it is less important. So, what to do next? When you will get, oh no, I'll do an announcement. Some of you did discover how to run GoSU in either Windows mode or Linux mode right away on this laptop. I have no doubts in your intelligence. But we need to do something a little bit more sophisticated. The goal is not to torture young thinkers. There is an important goal. So we will do not straightforward, not elementary thing, a little bit next level. So we under Linux, which you may have already opened, we need to open a terminal and log into high performance cluster. Not yours, so you shouldn't be using one or another cluster. So please, do you see it from here? Before you were using this, yeah, this username, right? Right now, remove the lab, use only this one. Your directories that you created last lab will be there. It's just a little more efficient. And I will show not to the camera. Yes, SSH and Russell will explain as a biggest expert in Linux here why is better than else. It should work the same way. Don't ask me why. In reverse order. No, in direct order. Raise hand when you need the password. All lowercase. Another one. I hear you. Not a problem. You have number one. So, please give me a sign if you didn't log in or something went wrong. Okay.
You can do few of the avoid like you try to times.
So.
So after you are there, you can go to your to the directory of the course, C D Chem476 LS and identify your subdirectory. So please go into your subdirectory. Let's go into your subdirectory. And you will see, is it possible to see this one? More or less. So you will see your subdirectories. Just go into whatever is your preference. And I think you do, and then type GV with GV, and then this crazy symbol.
Whatever is with or with it doesn't matter.
Yeah, this space probably is safe, but shouldn't matter. And then you should get a window like this. So please make sure that you came to this window and give me raise hands if it didn't pop up. Yes. But you are entering Gauss view not on the local desktop, but on the remote computer. Why? 100% yes keeps you able to type in normal commands. Yes.
You know, she can't make me better.
Waste time on the creative.
I'm just drawing out my catalyst.
And you're using the Roberto instead of.
Yeah, I was just messing around while we were waiting.
Okay.
So everyone is in the Gauss view window. And I see that some of you do not need this instruction because you are efficient with drawing models. So let me disclose the goals so that it will be not a secret. So what is the plan and when we declare that the goals are done? You all know by now how to draw models in the Avogadro. We need to get the same skill in Gauss view with a specific. So Gauss view gives more options. Some people can do things intuitively and do not need these options, but for other people they are helpful. So if you look here, you will see a lot of menus, menu tabs, much more than in Avogadro. All of them are useful, especially if you want to create complicated models, not like acetylene or methane, but something advanced. There are ways to measure interatomic distance, and upon the model has been made, there are ways to modify the geometry, change some parameters directly. Then, as usual, we need to be able to load and save, especially save the model in the form of coordinate files. And then we will go back into the command line and submit this job for execution. I want to give you, so upon each of us will be able to run one successful job, Gaussian job, on the supercomputer. The goal for today's meeting will be done. Okay, makes sense? I want to give you a backup plan and a hope for an easy life, which I'm not going to pursue, but you have always a way to survive. The computational chemistry software Gaussian and drawing software Gauss View are two pieces. They are independent. But if the system was installed by a skilled system administrator in the right way, they are naturally connected, and you can run jobs on a cluster by clicking mouse in Gauss View. For beginners, if you need to quickly calculate one or two molecules, and you are not looking on yourself as a professional in this area, this is a really quick way to get around. This opportunity is available both on the HPC cluster where we are logged in. Upon you build a model, you can execute it just by clicking a mouse. I will not show how to do it. You figure it out yourself. But why? Because it is very far from high productivity. If you want to be a professional, you need to do high throughput jobs, mouse clicking will not help. If you need to run like 100 or 1,000 jobs, you will not click mouse 1,000 times. There is a way to submit in a command line, and it is a little harder for the beginner, but much more, and it is the only way for professional productive work. So I will go directly there. For this first step, we will feel a little bit of pain, but later it will be highly rewarding. So if something doesn't work, if you do not, if level of pain is too high on a scale from 1 to 10, the local desktops do have installed Gauss View and Gaussian. So you do, in fact, you do not need logging into the computer, logging into the. If you are Angela?
Yes.
So we are making meeting in the other room. Only this time. Next week we will return to QBB. But please keep the system running for some time, because some students may come to those rooms, and I want to announce just to invite them to come into the other room. Okay?
Okay.
Yeah, thank you. So, a way out. All these Linux desktops are equipped with Gaussian and Gauss View, and you can do this one-click running immediately. So this, if you need to make presentation of how Gauss View operates, and you feel difficulties in this cluster things, it will be your bypass. But it will not help us for productive job, because single core or even 4-core CPU on these desktops will not be able to run most of jobs that we need. So it is only this saving opportunities only for a short time, just to get some skills. We need to learn standard procedure, standard protocol of creating and submitting jobs on the cluster. Today, we will have a little bit easier life in aspect that we will directly build model on the cluster and run job on the cluster. Sometimes people build models on local computer, then send files out and then run it there and then download back the results. But some of us are impatient, we are doing it for the first time, and we are doing both graphical part and computational part on one remote cluster. Any questions about general global view? Okay, everyone has this thing, right? So what we do is to click on create molecule group, and then you may figure out just every of these operations by clicking randomly. The first menu tab here, if you click here, you will be able to select element. As chemists, you know that molecules consist of atoms, and atoms are of different elements. Most popular is carbon, but in addition, you know that in typical traditional molecules, unless it is something really exotic, there are very few symmetries and coordination numbers for atoms. And those standard opportunities are listed here for each atom. So the goal for this is to minimize unsober handshaking. So if you are going to do non-conducting hydrocarbons, this 4-coordinated is most typical. If you want to do carbon nanotubes or benzene ring, you may select this 3-coordinated. So you select whatever coordination number you like, you need. Go to the window with your model and click. Okay? And then you point, if you want to continue the same coordination, you see that, so here is our model. We have 1 carbon, 1 compensated by hydrogen, and 2 dangling bonds. And at the end of this bond, we can put a new atom. So we can put another carbon here, right? Suppose I do want to do benzene ring, or if I'm impatient, just shorter chain. Well, if I want a benzene ring, this will not work right away, right? I don't know how to explain it by words. But hydrogen should be on one side, and here they are on the different side. How do we fix it? Well, if you would do it in Avogadro, you would just click carbons first, hydrogens next. Here, I'm going right away at this simple example to other points of menu. So they are here. The interatomic distance, the angle, and dihedral angle. For me and my physics background, the word dihedral was a killer. I was scared to the death. So I will go systematically, but right now actually we need dihedral. So if you select the menu for interatomic distance, let me make one note, especially for those who will present on this aspect. You may want to present the things, and what if your laptop doesn't have this externally? It will be not helpful to those who will listen to you just to make hand wave. So please do print screen. There is a print screen button in this Linux machine, and then if you open any of the analogs of PowerPoint, there is an analog, like Star Office or whatever, and you copy paste your screen image to there, and then email to yourself. Or you can do a snapshot with your cell phone, but it will be low resolution. So please think about it, because when we will be done and time will be over, it will be too long to repeat these things. So if you are presenting on Gauss view, yes, do this. Figure out
It's been painful. I think I got it now.
print screen and making some sort. You can funnel images through emails, or you can do analog of PowerPoint and paste those through. Okay, so interatomic distances. Clicking on this stuff, and then there appears another window that shows what is the distance between these two atoms. Right? Now it was an educated guess of Gauss view, but if you do not like this distance, and again, you do not believe in your soberness or in the strength of your hand, you can just pull this bar. You see the distance between atoms is changing. And if you completely do not believe in your hand, you can just type the interatomic distance that you believe is correct. Okay? Same about, and then when you are done, you click OK. Also, right now it is the order of bond is 1.5, right? Conjugated bond. So in chemistry audience, this now doesn't induce fear. Okay. for pure physics persons, it can be another point of being scared. But if you like another bond order, you can click here. No bond, triple bond, or whatever. When later in the class, when we will do pure electronic structure methods, DFT, the computational procedure, computational algorithm doesn't care about the bond orders in here. But if you do force field, the parameters for potential energy surfaces are different for different bond orders. And it is like honey for the eye of chemist to see one or two lines. It's more informative. So we keep this, we could do it double, you see, or triple, but we will keep it 1.5. Okay. Now, next thing, the angle. It shows modify angle, but also it measures this. So you can click. When we were measuring distance, we were selecting 2 points, right? When we are measuring angles, we select 3 points. Your primary school or middle school math supports this. Right? So here's the value of angle. If you do not want to change something, but you want just measure. And if you want to modify it, you need to decide which atom will be nailed to the screen and which will be moving while you are changing angle. So for example, I want to nail down number 2 and move number 3, right? So you can play with the numbers here. So atom 1 rotate group, atom 2 fixed, atom 3 rotate group. Okay. Now I take the bar and start moving. Ding, 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 ding. Okay? Good? If I mess up and do if I do differently, then it will this one will nail down number 1 and make the rest moving along it. A little different motion. But if you want to minimize time of optimization, you may use these tools to create a more precise model. Okay. So please lift hands if something doesn't, try to repeat it, and lift hands if you need on-site assistance. If you don't, please repeat those exercises and make screenshots, especially if you are presenting. Right now, those who will present tomorrow are in less luxury situation than I am now. We have 2 hours, and presenters tomorrow will have like 3 minutes. So you need to just squeeze a couple of snapshots and do this, this, this. Questions? I'm done.
Optimize.
Yeah.
Because right now my brain is very cluttered.
Well, the optimization that is available in Gauss view is not a true optimization.
How do you make it free?
Huh?
How do you make it free, right? On an optimization like in my optimizer. So like right now I have this mess. Like, so I can plug in the question. It's too weird. Sorry, it's a little wonky.
Well, maybe for field optimization will not help, but you need to do the true. Like everything that includes metals, transition metals, is problematic for force field.
Okay.
So force field is good for hydrocarbons, oxygen, nitrogen. Okay, and now the most scary word. Please lift hands if you never heard the word tetrahedral. Oh, you are so educated. I've learned this word 5 years after getting the degree. So we are going in progression. Connection between 2 atoms, connection between 3 atoms in form of angle, and if there are 4 atoms, it is tetrahedral. So click on 1, 2, 3, 4. So right now you see, so the tetrahedral angle is how much this group comes out of plane. So right now the angle is minus 180, meaning that those are opposite. If they would come to the same side of this line and stay in the same plane, the angle would be 0, right? If it is will be like going this way, it will be 90 degrees. And we can practice it. I don't know why I'm using so small. I can use a bigger instruction. And if you have a rolling wheel on your mouse or 2 fingers gesture on your trackpad, you can enlarge or shrink it. So now you take the bar and play with tetrahedral angle. You can also just rotate it and put it in the way you like it better. And practice it again. So this is an illustration what is tetrahedral angle. I don't know how one can show it in snapshots. This animated thing is a little better. But if we set up the, like my hand doesn't allow me to stop at exactly at 0, so I would better put 0. And then we see that those 2 hydrogens are on the one side and uncompensated bonds are on the other side. Okay. And now I can maybe complete it as a benzene ring or do something simple. We're going to carbon, maybe one more. Oh, this one was not lucky. I probably can modify this tetrahedral angle again and do it. To 0. Okay. And let's put one more. Let's put one more carbons. Well, there is a button to delete atoms, and it also should apply to the delete uncompensated bonds. So since we will be optimizing with force field, I want to make sure that here is the type of bond we like.
Cheater.
So I do have a model which may be far from perfection, but it is time to check if we can do something with it. If you want some quick optimization, we could click on the broom, but I intentionally want the broom means educated guess optimization. It's not true, but I'm going to avoid it and start with the ugly model and just check if I can go through submission of a job. And then we will return back to building models for other opportunities. Some aspects are missed, but I just want to make sure that we get the main part guaranteed. So we are saving it. So I just fear C6H6, something that identifies this. It's already there. No. And type of file .com. Now there is a menu calculate. So it is, it shows, and there is a Gaussian calculation setup. So in very narrow sense, computational chemistry is a skill to operate this menu. If you know how to do it, you already and then know how to interpret results, you already can publish or add a paragraph on computation into your experimental paper. So you see several menu tabs, but we will go only two first. So job type, it is what we need optimization, which means optimized geometry. Same thing as we were doing in class when we were pretending that we are little computers. Then method. We do not know what Hartree-Fock is. We go with mechanics. And then after selecting these two options, so job type optimization, method, mechanics, we are going to submit. So the software complains that before submission you need to save file. Yes, I agree to save at the same name. File already exists, overwrite, yes. Good. Now it asks, submit the following to Gaussian. If you are impatient, if you want a shortcut, you could click yes. I will click no. Because I need for myself a skill to submit jobs from command line. because I know that I will not be able to click this again and again. In the future, I will be copying text files and submitting them without looking on the model. And then it will give an opportunity to run for much more jobs. So here I do click cancel. And then I'm going back into the command line. So there I do. Please stop me and raise hands if I'm going too quick and you are not following in repeating. I'm getting too excited, but you need to do these things in parallel. Anyone needs detail? So here is the file, the directory C6H. The directory and a file that we have just created. I can look inside and Gauss does different formats, and Gaussian input files are versatile in a sense that the geometry can be saved in the form of Cartesian or connectivity list or just interatomic distances and angles, so it is universal. You see that at the top there are orders. Which type of job we will be practicing. Those are very brief coding, but it is the only command that we as humans give to the software. So, unrestricted force field, it is a type of method. Force field means that there are potentials, there will be no true outflowing structure. OPT means that it is optimization, and it tells how the geometry is saved. Another thing that it tells CHK, it is a file where intermediate data are saved. At the beginning step, we do not need to know much about it, but it needs for healthy functioning. And then, before we go to geometry, there are two numbers that we will focus in subsequent weeks. But it is not a big secret that it is a charge and multiplicity. So 0 and 1 stands for neutral single. And for closed shell molecules, it is very typical. Okay, now we type run gaussian. We tell the name of the of this input file, and minus S4 stands for adding additional scratch space. S for scratch. So after I type it, I hit enter. It tells that job has been submitted, and then I type Q stat. So you see there is a number of job 60041. Here is the 60041, right? So right now we are doing training, so we are executing only on one CPU, which is pathetic, but for this we do not need more for force fit. Yes.
What if we change the name? So instead of Gaussian, you change that name? If you have multiple jobs.
Yes. There is way.
You have to go into the thing.
You need to prepare additional modifiers too. And letter R stands that it is running. Since this job is very quick, if I repeat this Q stat once again, you see this job is not any 60041 is not there anymore, and probably 60040 was someone of you. It's also complete, right? So it disappears from the list. Now we do list of files, and we see that number of files did increase. 2 minutes ago, we had only this c6h6ff.com, and now there appeared file with job number out, job number error, and then chk and out. If the job would be malignant, instead of 4 new files, it will be only 2 new files. But it looks healthy. So if the out file did appear, it is hallelujah. Good. Another check, if the job has completed successfully, before we go into the science, we can explore tail of this out file. And at the, so you know command more, show the file without editing. The command tail stands show last few lines of the file without editing, like head and tail. Okay? So tail of the file, see, do you see what it shows? Normal termination means very good. Everything we requested has been completed. So let me go around and make sure that you all are able to run it. And then I will return back to this podium and go to analyzing of this output file. I'm stupid in changing fonts. I would be very happy to change font with this screen and software.
Sorry, I didn't keep that.
No more termination. Okay.
Yeah, right. Yellow is actually what if we here.
So please help each other if some of you are in trouble, so that we spread information across.
Okay, so that is over.
Have you tried about it?
I was trying to read it.
Yeah, that's how you
Well, I got the 4 as the S on short.
Oh.
So. This is just one gas.
Oh, that's hard. So, exactly.
Yeah, I know, right?
How did that happen? That's what
Yeah, basically. I might just, I might just make something. Probably the smart thing to do now. That's getting too fancy. Okay. Yeah. Mouse wheel is backwards.
Oh, yeah, right.
That's what I just too much.
Oh, that.
Yeah. Oh.
That's like, but like, it's just,
Fair enough.
it's not.
Yeah, that's what. Who are you talking to? Good. Okay. Yeah, we would be lying. Yeah. Maybe it's the maybe it's so all I did was I went to this, so I did that scene, and then just put it on my measurement. So
Well, right, yeah.
that one just ended up being really nice.
When you click on the bottom
Oh, then I switched it to nitrogen here.
Well, yeah.
Like,
Oh, okay, so you did click 3 times.
yeah, it just took its time.
Yeah.
Yeah, mine finished in like 2 seconds.
I did that. I'm just kidding.
I don't know, but like, I could see. Last year on the laptop, and it'll work on here. This is fine, but try. That is. Well, actually,
Yeah.
so sorry,
Three period.
oh, 13 is like that's even. So like, what if would it be like? If you like flip the one around with that turns into a trans.
Well,
I don't know how that's solved.
so this is a ligand, and so most often you would have put a metal down here. So then you should use nitrogen, but you just add to that.
Okay, so you wouldn't really have to.
No, you would have slight banging of the security by itself, but as a whole, it's pretty cool.
How do you?
And then.
So please raise hands if your optimization job didn't go through. 1, 2, 2, right? Your job got normal termination, right? I'm asking who didn't got normal termination. Okay. And I'm making an announcement just in case you came a little later. So, who we are and what are we doing? We are preparing for presentations tomorrow, but our goal is to build atomistic models and be able to run simple Gaussian jobs on supercomputers. Many of you did access Gauss View on local stations, but now we are practicing building model, saving model, and running optimization on a single machine, which is remote, this HPC cluster. So if you got Gauss View, it is not here, not on local computer, but there. Upon you build a model, whatever you like, something simple, you save it, and then go to command line and submit Gaussian job in the command line, and make sure it has normal termination. Gaussian job, to save time, will be just force field optimization. So in the Gauss View